Cool. Hello, hello. Hi, humans. So yeah, I'm PJ, Peter John, if you want to call me my full name. Um, I'm the mobile engineering lead at DVT. Don't really know what that means, but uh, yeah. So if you've known me for a very long time, I used to be a very big Apple fanboy, hence the Mac, and but I'm not really anymore. But that's kind of my gamer name, so like I ended up just being PJ Apples everywhere. So that's pretty much what happened. But yeah, today I'm here to talk about serverless functions. So what are serverless functions anyway? Yeah, so let's dive into it. Let me talk about myself for a bit. Something about me is that I'm South African. Yay. Apparently, you should put that you're South African on your slides, especially if you like go overseas and stuff. Like people do that. Like if you from somewhere else. So I'm like, okay, I guess I just put it everywhere. I'm one of the organizers for GDG Johannesburg. And those are pretty much the stacks that I play on. So Android, Firebase, Google Cloud, iOS development. It's kind of what I do. Also one of the organizers for the Dev Fest. So yeah, hopefully we see some of you guys there. Woohoo! Yeah. So before we jump into serverless functions, I want to go back one step. So I want to go to a point where back in the days, we used to work for companies. I don't know how old some of you people are. But we used to work with companies where all of our servers were all on-premise. So everybody was going around and they were buying blades and stuff, and everybody was buying all this fancy equipment that we had to upgrade every single year because it's not fast enough anymore. We don't have enough RAM or whatever and stuff like that. And then eventually we moved on from that, where we went to a place where we went to infrastructure as a service. So what this means is that we were like, okay, we're not going to buy our own hardware anymore and put it in our premises. We're actually going to take that hardware and we're going to put it in some cloud somewhere, or we're going to ask Microsoft or Google or whoever to give us some kind of like machine. And we're gonna go and configure, and we want this spec and that spec and blah, blah, blah. But we're gonna still manage everything ourselves. And that was cool, and people still do it these days, but who wants to manage VMs and stuff like that? Like, it's kind of boring. So then we went to platform as a service. So platform as a service is another place where you'd write a whole bunch of code and you'd actually just deploy it to this platform, and this platform would serve that type of I don't know, like server, or serve your web, your API or something like that for you, and that would be all cool and stuff like that. But I mean, that's something that's pretty cool. But I mean, it's also kind of like a little bit bleak, because you still have to like manage like memory and all of those type of things. And then obviously that cool picture at the bottom there shows our progress all the way to serverless functions. So obviously can't come here without memes, because it's like the meme house. So I thought, let me get a meme and say, dude, it's serverless architecture everywhere these days. So pretty much that's what everybody's talking about these days. Pretty much everything is serverless. And what does serverless even mean? So what is serverless infrastructure, or serverless, this word that people keep talking about? So it's an invisible infrastructure, but there's still a server. So it's serverless, but it's still a server. But the thing is, you don't manage any of that server. So I'm going to go through how serverless functions work and what serverless is all about, but pretty much it's infrastructure that you don't have to worry about at all. It's also auto-scaling, so that means that you pretty much don't, if you have high volume traffic coming towards your server, the serverless infrastructure will scale automatically, and you don't have to worry about that, right? The other thing is that it's event-driven. So what makes serverless really, really unique is that it's pay-as-you-go. and pay-as-you-go, meaning only when someone actually uses your serverless, your server, or the serverless function or something like that, you'll pay for that amount of time. So if it's only being used for 3 seconds, you only pay for 3 seconds. And how that works is it's event-based. So if an event gets triggered or something like that, that's when you actually pay for that piece of you pay for that time that you use, and as soon as you stop using it, it pretty much shuts down. One of the drawbacks of that is obviously sometimes if you don't use it for a very long time, you obviously need to warm up the server. So that could kind of be sucky. So the 3 biggest providers for serverless at the moment is obviously Google Cloud, there's AWS, and then there's Microsoft with Azure. I've tried the Google Functions, because if anybody knows me, I'm very fond of Google stuff. I did try AWS. I was like, what is happening there? AWS is like insane. Their documentation is really bad, according to me. Microsoft was also really, really awesome. Their CLI was quite easy to use. I got some functions up and running, but I couldn't get, I don't have like Azure credits and stuff, and then like stuff started not working anymore. So I'm just not going to show you anything. Azure, I do have credits, but I don't know how they work. They're on my account, but I don't know, like they were asking me for credits when I was trying to access stuff. So I was like, I don't know. I probably did. That's definitely something that I would do. So Azure is really, really cool. They have logic apps and stuff like that, which work really, really well. I have some links to some really, really awesome some awesome documentation and some guides and stuff at the end. It's really, really awesome. So definitely check that out. So, but now I want to move into the realm of serverless functions. I've been talking about serverless infrastructure the whole time. What is a serverless function? So a serverless function is pretty much code as a backend. So so everybody's like probably thinking like, yeah, but we all write code and we still put it on the backend. But this is literally a piece of code, a file that we export and we put it on some kind of a server that we know nothing about. We're literally going to deploy a function, a piece of code, a JavaScript file, and it's going to go all the way to the backend. And we don't really care what's actually happening with the servers and stuff like that. So it's pretty much code as an infrastructure. And then don't shoot me. I think this is actually the good crowd, but like I'm going to use the word microservice because I know when I speak to Java people, they're like, microservice is completely different to them. And then they just like, then there's always like this war and stuff like that about what is a microservice. But serverless functions are considered microservices in the fact that they pretty much provide you with one small thing, and you're going to hit that thing and it's going to give you exactly what you need. And it's all small and compact, deployed in one place. So I would say that it does consider as a microservice, but again, I won't say microservice anymore because I know that people don't really, really like the whole microservice thing when it comes to serverless. There's always the war around that. So why should we be using serverless functions? So as a developer, to be honest, like I don't really, really want to know anything about load balancing. I don't really care anything about scaling. I don't want to know about how much memory is on my server. I just want to write code. So serverless functions are really, really awesome concept because all we're going to do is we're going to be writing some code and we're going to go into the command line and we're going to say deploy, and then we don't care. And then it's running, and then we're like, sweet, this is happening. Other things that's really, really awesome that, because I didn't try the AWS, I don't really know because I couldn't get it up and running, but with Microsoft and with Google, you get authentication to all of their cloud services. So like with Microsoft, you get access to their cognitive AI services and all of those type of things through cloud functions, and you don't actually ever have to authenticate. So that's something that's really, really cool because you have an account, you serve the cloud function, and it automatically gets access to all kinds of services. What's cool about that also is that obviously everything is secure because you're running it on their infrastructure. Everything is secure, and it's the same with Google. They have machine learning APIs which I normally use, and serverless functions work really, really well with that. And then obviously it's fully managed, so they do all the DevOps for you. So you don't have to care about any of the DevOps. I know I'm like going on like, hey, they don't do anything. You don't have to do any of the infrastructure, but really it is managed by them. Yeah. So there are two types of functions. You get HTTP functions, which are normally what people use for like creating APIs and stuff like that. And then you get triggered functions. And these triggered functions are the ones that are event-based, based on, like with Firebase, you'll have an event that happens in your database. And when something changes, you can trigger a cloud function. Whereas you're explicitly hitting an HTTP serverless function if you're trying to look at trying to do one of those. So what is it actually good for? Why would we want to write this? Because obviously the serverless functions are awesome, but there's a use case for them. They're not there for everything. There are small use cases for them. Some people, I've been discussing with people that they actually run their whole logic stack on serverless functions, which is really, really awesome. But these are kind of the main use cases of why you should use serverless functions. So creating webhooks, you want to create small APIs to do small little things. If you're doing something like a welcome email or something like that, when someone gets added to registers on your website or something like that, that could be cool. Again, third-party callbacks. That could be to your Google services, your Microsoft services. It could even be to, if you want to do payment gateways to like Stripe or something like that. That could be really, really cool. And then obviously for IoT, I think it's a really, really good use case for IoT because it's lightweight. You can do lightweight data transfers between them also. So serverless functions are really, really good for those use cases. But they do have their place. And then obviously there is a place for other types of functions also. I mean, other methods of having a backend. So just some languages. The one I did forget was F#, but so if anybody knows me again, I really like Kotlin. So I'm going to show you how to write a serverless function in Kotlin. But it's Jozi.JS, so there is JavaScript. I promise. So there is JavaScript. So, and I'll explain how it actually works. Like it's like just transpiles the code back into JavaScript. It takes all the Kotlin code and puts it into JavaScript in one file. So that's cool. Then obviously C#. So what's cool about the Azure functions is that you can write them in C#. You don't actually have to write them in JavaScript. So that's cool. You can do AWS. You can do Java if you really want to do that. I don't know who still writes Java code. And then you have Python. Python good for data science. I don't know if it's really good for doing serverless backends. Who knows? People use it. And then there's JavaScript and TypeScript. And those are pretty much the main, I don't know, the main guys in the whole serverless function world. So cool. So I'm gonna take a step forward, and I'm just gonna tell you more about because I'm more in the whole Google world. I'm gonna kind of move into like the Google space, so Google Cloud Functions and like Firebase functions. So pretty much this is again just showing you some of the integrations that we can use. So you have HTTP endpoints, which are pretty much for your APIs that you guys are gonna create. You have Firebase hosting. So previously Firebase hosting was only static sites. So pretty cool, static sites. And then now you can actually use, and you could never ever really write dynamic content for it. So what you can do now is that you can use Cloud Functions to actually serve dynamic content to the website if you do need something like that and running on the Firebase hosting. One of my favorite is the Crashlytics integration. So with Crashlytics, it's quite awesome. If you have an app and you get crashes and stuff like that, you can actually run, you can trigger off Cloud Functions that will actually send reports to like your managers and stuff like that, and you guys can create like proper reports of what crashes actually what crashes actually happened that specific day. So that's really, really cool. And then there's just like PubSub, Cloud, you can do like push notifications if you want to based on specific things. So Firebase has a whole suite of things that you can actually do. And again, like I said, everything is authenticated already. So you don't have to do any authentication with Firebase to access any of these APIs within your serverless functions. So obviously, everybody likes examples. So I'm gonna show two examples. I had a third, and then I broke it yesterday. So I'm just like not gonna show that one because I'm super bad. But just so this is like demo time, but this slide pretty much shows like you can npm install all of these CLIs. So that's the Firebase one, that's the Google Cloud one over there, Azure, and then yeah, I don't know how to npm install like Lambda functions. So I just put a web link there because like it's ridiculous. Cool. So what I want to show you first is I'm going to do this. What is this thing called? IntelliJ. So what I'm going to do also is I'm not actually gonna like do all the commands, because the last time I did some commands, like we waited for dependencies because I was really relying on the internet, and then the internet became really bad, and then I had to like do stand-up comedy for like 2 minutes. I don't know, you can't even see that. Cool. So I'm just gonna. So the first thing. So what you do is you pretty much. This is pretty much for Kotlin.js, right? So what you can do is you go into IntelliJ. You make a new file. You make a new project. Create a new project. And then what you do is you go down to Gradle, and then you can say, hey, I want a Kotlin JavaScript project, right? And then from there you go through all the steps and stuff like that, and just create the project. And then you'll end up with something like this folder structure over here. And at that point, you will have to then create a Firebase Cloud function from the CLI, and you go into this directory of this folder, and you'll create the CLI, the Cloud function itself with all the dependencies and stuff. So it will create the package.json, all of those type of things, and give you all of that. So you can see over here, here are all the dependencies for, sorry, I don't know, what is the plus? Control plus, command plus, nothing works. I don't know how to make it, where's presentation mode? So that's pretty much the packages that gets added. You can see there Kotlin functions, and then Firebase admin, and then there's just a log file over there also. Cool. So I'm going to be bad and just enter and exit it the whole time. Then the next thing that you have to do is that there's this small piece of code over here. So this piece of code is pretty much telling the project, the Gradle project that you've created, that this Kotlin.js project is going to run on the back end. So you have to put this small piece of code over there to say, hey, this is going to run on the back end. Otherwise, it thinks that it's a front-end project. So it is what it is. Just put the 3 lines of code, and then magic will happen. And then finally, we get to the actual code. So then you're going to create a JS file, and go away. I don't want to see that. Then you're going to create a JS file, and then you're actually going to create your functions at this point. This is the wrong one. This is definitely the wrong one. No. Where did it go? Okay, I'm just going to explain this one because I don't know where it went to. But pretty much, you'll create a main function over here. And what this main function will do is that it will, how obviously with Kotlin, you need to have a main. It's kind of like old school Java with arguments and all of those type of things. This is actually the generated code. I don't know why. Sorry, wrong. It's the wrong one. Yeah, that was the source one. You have to create a KT file, obviously, because you're writing Kotlin code. So you have a main over there. You have your arguments and stuff like that. You can import your you import your modules over there, and then from here you can pretty much do your normal stuff. So you're gonna going to require Firebase. So it's pretty much, it looks exactly like JavaScript, right? Kind of, yes, no. People are not nodding their heads. It looks like similar, right? Yeah, I don't know. I don't TypeScript, so I'm just gonna go with a yes. And so you have your requirements there. Those are the modules that you're importing, and then you're pretty much gonna create an export function called saveString. This is an HTTP function that does a request, and then it will get the text from the request, and then from there it will pretty much put it into the Firebase database, and then send back a 200 and say, hello, whatever. So, and how we run this is that we're pretty much going to go into the command line and we're going to say Gradle build. I'm not going to do it because it takes a very long time sometimes. I don't trust Gradle. So I'm just not going to do it, but then I'll definitely show you the function. Yeah, there is a lot of stuff happening here. I want to go to any one of these and create a tab, and then go cloud functions. I'm sure this will be fine. So I'm just going to my cloud functions, Google Cloud. And I have this function that I've uploaded over here. So what's cool about the Google Cloud is that it has, you can pretty much edit, copy, you can even write code inside of the Google Cloud if you really want to. Except if you use TypeScript. I have no idea. I actually don't know. But yeah, so you can see all the invocations, you can see the triggers, what will actually trigger this function over here. And you can actually see the source also. So the code is over here, and you can actually go and write. You can write code in here and like redeploy from the Google Cloud if you really want to. But you can see like it's all generated stuff now based on the Kotlin code that was built. And this is what I was talking about. It pretty much creates that and creates this meta file, and then it will create your package.json. So that's cool. And then there's obviously like a testing place where you can actually test your functions. But I'll click on this link. And cool. So then I'm going to do this. Hey, look at that. So what I did over there, so automatically we get SSL also, firstly. So all your security and SSL stuff is all done for you. You get HTTPS out the box, which is awesome. And then obviously I'm running in US Central. That's my cloud function URL, and that's the thing that I created. So I can go Jozi.JS, and then what it will do is it will pretty much like invoke the cloud function. This is what I was talking about, explicitly invoking cloud functions, right? So then my second example is actually gonna not be Kotlin stuff. It's gonna be actual JavaScript. So I'm gonna go VS Code. I don't know if I opened the right thing. VS that thing. Cool. So this is another function that I wrote. How do you make bigger? Hey, it worked here. Didn't work. Yeah. I'm not gonna deny anything, dude. It's not that bad. So over here, I don't know if everybody can see. So what I've done over here is that I've created I'm creating a serverless function that what it will do is that I'm going to upload. So I've written a random iOS app where I'll upload photos to Firebase, and based on that event, based on the actual picture getting uploaded to Firebase, it will trigger this cloud function, and then it will go out and to the Google Vision machine learning API, and it will look for any annotations on the web that actually describes this image. So pretty much what I did, some modules over here. I added some modules. I added the Google Cloud Vision module. And then obviously I need the admin access. Again, you can see I'm not doing any kind of authentication because I just have authentication because I'm uploading it. It also knows about my Firebase account based on the project that I created on Google Cloud. So obviously you have different Firebase projects. You need to upload it to the right one so it can actually monitor the right database. So then I'm just going to go and I'm creating a call vision, and I'm saying, hey, storage, go to the storage, and on any image being uploaded over here, trigger my function, get the bucket name, go to the file path, whatever, and then pretty much do a web detection based on the image that I'm actually uploading with the Vision API. So you can see it's just some random JavaScript. It could be really bad JavaScript. I at least returned my promises. So I'm not that bad at JavaScript. And yeah, so that's pretty much it. And then what I did is that I took the things that come back from the API, the Vision API, and I first logged it out because obviously I'm testing live, live testing, and then I put it back into Firestore, and at that point I'm then showing it on the app. So let's see if this thing works. I am gonna open Xcode, sadly. And this is the random app that I created. Code's really, really bad. Please don't butcher me for it, but it's all just in one file. So I'm gonna run this bad boy. And let's see what happens. Hopefully Xcode doesn't explode on me, because Xcode is known for explosions. Yeah. The only one I probably didn't use is like Python or like Android Studio. Maybe I should write an Android app for this. I think people will be more happier with me anyway. There's still time. No. Yeah, well, Xcode didn't explode this time, so it's okay. Yet. You speak the truth. Okay, something else happening. I'm just gonna do that. Yeah, 2 emulators running at the. Yeah, I don't know. My PC could be in a very fragile state at the moment. Meh. So I'm going to take one of these random photos. I guess I could go and find a photo actually. Let's do that. What should I Google? Let's go to Google first. This is actually a clean emulator, so this is if it works, then it's actually the legit thing. This is not even like tested. A cat. Yes. You guys really a cat? Cat memes. Cat memes. This seems, I don't know if this is safe for work. But that library, check images in it and tells you this is risky. Yeah. But like this is okay. I'll just take this image. What I'm gonna do is I'm gonna try and I know how an iPhone works. Cool. So what I'm gonna do is I'm gonna go back into my app, and there's a random cat that we just Googled, and I'm gonna put this in. And then what it's going to do is it's now going to, so this is because I didn't clean the database. I'm really, really bad. From the previous image. So what it's going to do now is it's going to go out, it's going to hit that cloud function, and it's going to come back with some kind of entities found for this specific cat. We can actually go and look at it at the cloud function while we wait. Sorry? No, I clicked upload photo. See, I'm really bad with names also. Where I clicked upload photo to open the thing. Yeah. It could be any one of these. Let's see. I'm hoping it's this one. This looks good. Today. No errors, that's good. Logs. Hey, look at that, it came back with whiskers, cat, kitten memes, internet memes, all of those type of things. So pretty much, don't look at the warnings, just look at the logs. So I executed this function like a minute ago. So it did have to warm up because I haven't actually used this function in a really long time. But so it found 2 matches, then it found some more stuff, and then it scores the images. And then I only want specific scores for the images. So this is just based on some machine learning stuff, blah, blah, blah. No one really cares about machine learning. And then we just care about the cats, man. And then pretty much what it did is that it said, cool, everything was executed awesomely. And then in the database over here, if we go to this, to the Firestore, we'll see there's images. That was the image that was uploaded, and then you'll see all the things over here inside of. Why can't I go down? You'll see all the matches for the things for the cats. So there are kitten memes, internet memes, all of those type of things. The machine learning stuff also gives you like actual URLs and stuff like that to go see other pictures and stuff. It's pretty cool. And that was all done with me just literally writing a random function. I said Firebase deploy, and then it deployed it to the project that I was in, the state that I was in, and I could pretty much like hit this function at any time and say, cool, give me data about cats, I guess. Cool. So that's my demo. I hope that was sufficient. Cool. I have way too many things open on my PC.
You mentioned the time limit.
The time limit.
Yeah, they won't run longer than 60 seconds.
Yeah, I don't think I've ever gone over the time limit. So I don't.
Put yourself in a recursive loop, it helps.
Wow. Yeah, that sounds bad. So I'm just gonna carry on. So a cool thing about Cloud Functions, and they released this recently. Excuse me?
You overrode the time at 120 seconds.
Yeah. So you can now actually do configurations at runtime on your functions. So you can tell it that, okay, cool, when I deploy this function the next time, I actually want to deploy it in a different region. Or there was a really, really bad issue with Cloud Functions where it always used to only allocate 256 megabytes of memory. Now you can pretty much give it as much memory as you want to in your Cloud Functions before you actually run them. And then again, the time. You can spend all the money. Like, money's not important, guys. Like, let's just spend the cash and like write awesome stuff. So you can pretty much now do this at runtime. Previously, you would have to like go into the actual cloud console and stuff and like do configurations there. Again, Cloud Functions are not supposed to be, you're not supposed to know how to scale and all of those type of things. We're developers. We just want to write some random stuff and we want to deploy our code and we want to see it working. So this is a really, really cool thing that happened. Then again, I just want to talk about, okay, I'm a big advocate for unit testing. So obviously you need to test your functions. So in Firebase, they have actual documentation of using Mocha to test your functions, but you can use Jasmine also. Jasmine works quite fine. And then also, I know that what's cool about doing it in Kotlin.js is that you can obviously use JUnit to actually test your functions. So that's actually quite cool. And then on the Azure side, you can also, since you're writing it in C#, you can actually use the C# testing frameworks also to actually test your functions. So that's really, really cool. So yeah. And then if you want to run it locally, so one of the things that a lot of people do is that they write a Cloud function and then they deploy it to the cloud and they're like, okay, cool, I tested, it's broken. Cool, run it, deploy it to the cloud, wait for it to deploy. Cool, test it, it's still not working. and then eventually they get it right. But you can also, with Firebase specifically, I'm not sure what the others, I didn't actually try it, I just did the try it, deploy to the cloud type of vibes. But with Firebase, I know that you can actually serve them locally, which is quite cool. So you can actually just test them in your browser quickly, just makes more for productivity. It was actually, should take out experimental. I don't think it's in experimental anymore, but it still works, that line of code. So I guess they just copy pasted the cloud, the CLI thing, whatever, the command. So that's cool. And then obviously you can also run your cloud functions on CI/CD. So Circle CI has documentation for Firebase. I was actually really bad. I had another link that I was going to put up there, but there's also links for how to run your cloud functions for logic apps for Azure functions. So I'll definitely add that when I give the slides out. But CI/CD is important. We obviously know that that's just part of our development process these days, especially in enterprise development. So having some kind of way to actually do it is really, really awesome. And then this is just some resources to get started. So these are all linked. The first three are just YouTube videos on AWS, Google Cloud, and Azure function. I keep saying logic. Azure functions. And then obviously there's just documentation stuff. And then serverless is a CLI that was written by this other company. It's a serverless CLI that actually can run any kind of serverless function. So it's really, really cool. You can run Google Cloud on there. You can run Python stuff on there. You can run anything you want to. So they have like a really, really cool CLI, and they have like awesome documentation, awesome blogs. So I think I've read almost all of them. They're really, really awesome. So definitely check those out for getting started. And then I just wanted to say, go out there and actually try it. Maybe see if you can actually get this working with something new within your company. Maybe try actually port one of your other functions, one of your APIs to a cloud function, and see what the performance might be. Maybe see if it works better for you. Maybe the triggers might be something that could benefit you. Maybe the whole thing about accessing different APIs that are already there for you to use. Maybe that will be really, really awesome for you to try. So if you need to contact me, there's my deets. Otherwise, thanks for having me. Does anybody have any questions? Any questions? Yeah.
Might be misunderstanding, but the serverless function that you call, can you return the entire static generated HTML? And you register it by a domain instead of like an API URL?
It's the hosting side.
I think you can. So it's pretty much I think you can return anything you want to. I'm not gonna lie, I'm not really sure. I've never tried that before, so I'm just gonna go with maybe.
It's one able to configure the actual API URL to make it domain specific.
If you want to make it domain specific.
So
Yeah?
I've tried that. On the functions you can't.
Okay.
But on the hosting of Firebase hosting, you can configure the domain.
Yeah.
And that's serving static content.
So I think.
Firebase's actual authentication is quite good. You actually set up your customized domain stuff there, and then you can use a DNS CNAT.
Okay, cool. Good to know.
Just pop in there, sorry, interrupted.
Yeah, go.
These cloud functions are not quite for retaining static content. They're more like an API and returning static content, but you can return whatever you want.
Yeah. So I think it's more for so I think Firebase, they really created these functions because Firebase was more of you have a client and you hit a database straight, and everybody was like, yeah, but where do I write my backend code? Like I want some type of computation, and they built these cloud functions so that you could trigger stuff based on that and then do some computation. So it almost serves as your backend or your API, where we traditionally go, we from our client, we hit an API and then our API hits the database. This is like from our client, we hit the database, and the database triggers some kind of functions, and then that does some callbacks and stuff back, but you can then render the data back into your app or your website or any of that. Cool. Anything else? Yeah?
Which cloud is the cheapest?
Which cloud is the cheapest? I'm
For
gonna.
for the serverless stuff.
So I would, to be honest, like Azure it's probably the cheapest, but I couldn't get it working. Like it was such a mission. So I wouldn't say go. If someone's really really good at Java, then I guess that, or Azure stuff, then cool. That's probably the cheapest. But I would say that I think Google has a free tier where you can do like I think 10,000 invocations a month or something like that before you actually start paying. But then it gets really expensive. Like if you get crazy, it gets expensive. We were just discussing earlier on. There was actually a guy with Firestore that actually got a $30,000 bill or something like that because he had some infinite loops running and stuff like that, and stuff just got crazy. So it can get really really crazy. But I mean, you just have to kind of I don't know. You have to do what you have to do. I think, and Azure, everybody has like Azure credit, so I'm guessing it's just free. I don't know. Like all companies have like these Azure partnerships, so like I'm sure you can get some free credits and then just like
Yeah, no,
Yeah.
I've been doing a crap load and never hit a single charge.
for Azure, for Firebase, yeah, yeah, yeah.
They've
Where
got
is
a
AWS
pricing.
charges straight away?
They've got
What
a
is it?
pricing page. So I found it accidentally one day. It's a really great visualization of how much you really have to push it before you even start getting a charge to send.
Yeah.
And it's like a whole list of these slider bars. So I'm thinking I'm going to do this, and then they recommend your pricing model, and most of the time it's okay, just go with the free one.
Yeah. So the one thing I can tell you is that some of the APIs on Google, so that machine learning API, you have to pay for that. So I was paying to hit that thing, get the bill whenever it comes. Who knows? Or they'll just take my money. But like so that's the one thing. So you have access to all these things, but sometimes some of these APIs and stuff like that are not free. So you just have to make sure that you use it wisely, and you make sure that you actually know what you're using, because you can easily use that machine learning stuff, and then all of a sudden, like you get a bill of like $400, and then you're like, where did this come from? And they just take your money. So like, go with him and then you.
Intellectual property and data stored in cloud, is it sold, or is there some sort of sensitivity on what
I would hope there's sensitivity because yeah, like this is kind of like they want you to run your business on this, so they should give you some sensitivity to your account. I know that Google has lots of like things around sensitivity, and that you own everything and you can like delete whatever you want and all of that. So I think sensitivity is very big. I think on all platforms. I think it's become like a law or something now that you own all your data. Yeah, irritating on web browsers. Yeah.
Is there like a notification system whereby like a real-time voice of like see this transaction that you just called and it costs 70 cents, and because you haven't reached your threshold, then you can like
So
get
you-
notification and you can stop.
So you can, so it has this integration to like push notifications and all of those type of things. I don't know if that's what you're looking for.
Yeah, your billing's a bit delayed.
Okay.
24-hour delay on what you see is what's billing.
Yeah, that he knows about billing.
In the Google, the cloud screen you had, the blue one, you'll see it has your invocations in real time, and there are blocks of billing, so you get 2 million free, and as you're hitting them, that count is going up. And then within Google Cloud, for example, we have 5, 10, 50, 80%. You set your budget, and we capped ours at $1,000, so you don't end up like a $30,000 guy. And then you get notifications for 5% all the time. If you can cap it if you want to, or you can do notifications. And those over there are in real time. I haven't seen a 20%
Yeah.
delay.
So there's one where where we hit that function now, and it's like pretty much instant, like showing the invocations.
There's actually a video about that story about those guys where they said exactly that. You put in your notifications and you cap it like.
Yeah.
You get an email notification or push notification.
So it's emailed by default, but
Yeah.
the cool thing is this integrates with all of the upsell push notifications, so you can actually just create a push notification project and send it to yourself.
Yeah.
So Azure is very similar. AWS is not.
Yeah, I think Jay was just saying now that AWS you have to pay straight up.
Yeah, you have to actually use third-party services for AWS like Cloud Health.
Mm.
Just breathing on Azure gets charged.
As an example,
I mean,
on cost, because I
AWS.
think that's what puts a lot of people off. We have a platform for vehicle dealerships where a vehicle and all its data, including 20 average-sized images for up to 100,000 vehicles, and the hosting and the costs for this got to like $4,500 for 100,000 vehicles with images is nothing. If there's one thing I can give Firebase is they are ridiculously cheap compared to the other ones. So we moved off of AWS onto this for that reason. It is really cheap. So don't have that much off.
Cool. Janice, do you have a?
Last night you have why?
Oh, so it's just the bird is a picture that I took. So it's just something that I do always on my last slide. I put a picture that I've taken. So I know I just change them every random. I do photography, so I thought, hey, let me also just like splash my photography out there while I'm doing tech talks. So yeah. Anybody else? Yeah.
So, if anyone wants to play around with the cognitive services from Azure, with the Vision API, that's free. So
Yeah.
you can do that exact same demo without getting charged.
Nice.
I was about
Yeah.
to say, oh, well, that's amazing. If you're interested in Azure Cognitive Services, one of
Yeah.
my favorite speakers is speaking on that next month.
Yeah.
Totally come and listen.
Azure cognitive services are really, really awesome. Cool. Thanks, guys.
Thanks, PJ.